Okay, question number 1. 2 to power 3x minus 8 is equal 16. So to solve this type of exponential equation, we need to know that if a to power x is equal a to power y, what is important? The base has to be the same. Then we can say that x is equal y. And that's considering that a is greater than 0 and a is not equal 1. Because if a is equal 1, so it doesn't matter what x and y, they don't have to be equal, right? It can be anything. Let's say 1 to power 4 can be equal 1 to power 5. So this statement does not have to happen, so equation would be equal to each other, right? So that's why cannot be equal 1, and a has to be greater than 0, because if it's less than 0, it's not gonna work properly. Okay, so what do we have? We have here base 2. Here we have 16. So our goal is to bring to the same base to be able to solve it. All right? So which means since base 2 is a simple number, so we leave it alone, 2 to power 3x minus 8. And 16 I'm going to represent by base 2, which is 16 is a 2 to power 4. Okay, since indeed we have same base 2 and 2 here, therefore we can insist that 3x minus 8 is equal 4. From here, 3x is equal 12. So is equal 12. So we moved 8 on this side, became positive, and divided by 3, we are getting x is equal 4. Okay, so the answer is going to be 4. Next question. Question number 2. We have 5 to power 3x minus 9 is equal 125. 125 is 5 to power 3. Why did I take 5? Because here I have 5, right? So since I have 5 here, then I can insist that 3x minus 9 is equal 3. From here, 3x is equal 3 plus 9, flipping over and changing the sign. So 3x is equal 12, x is equal 4. Next question. Question number 3. We have 4 to power x is equal 32. So from here, 4, let me see, to power 2. No, there is, I cannot represent 32 as by base 4. Let's see. 4 to power 2 is 16. 4 to power 3, it's going to be 4 times 4 times 4, 64, right? This is 16, and then times 4, 64. So there is no way I can represent 32 by base 4. But what can I do? 32 I can represent as a 2 to power 5. Can I represent 4 also as by base 2? Absolutely. 4 I can represent 2 to power 2. X and 32 I can represent as a 2 to power 5. Okay, so from here I have power to power, which is going to be multiplication. I will have 2 to power 2x. I multiply 2 by x because, let me refresh your memory real quick, a to power x to power y is equal a to power xy because we have power to power. Okay, so this is equal to 2 power 5. So base is the same. From here to x is equal 5. And x is going to be equal, dividing by 2 here, dividing by 2 here, and we are getting 5 over 2. X is equal 5 over 2. Question number 4. We have 2 to power 4 minus x is equal 1 over 8. All right, so 8 I can represent as a 2 to power 3, right? 2 times 2 times 2, 2 to power 3. But I have 1 over 8, which means 2 to power 4 minus x, 1 over 8. Can I write down as a 8 to power negative 1? Yes, of course. Remember, let me remind you the property of exponent. A to power negative n is equal 1 over a to power positive n. And accordingly, if I have 1 over a to power negative n or positive n, I can represent as an a to power negative n. Flipping, which is flipping over, which is it's going to be, it's 1 comes down and 8 goes up, but negative sign will pop up. Or if we have 1 over a to power negative n, then we will get a to power positive n. Well, 1 will go down. So therefore, 1 over 8, I represent it as a 8 to power negative 1. From here, 2 to power 4 minus x, I have 8 is a 2 to power 3 to power negative 1, right? Based on this formula, I can write down this is going to be 2 to power negative 3, right? 2 times negative 1. Let me make it better. Okay. 3 to power negative 1. And here we have 2 to power 4 minus x. From here, since we have same base, I can insist 4 minus x is equal negative 3. Since my x is negative, I rather move this x on this side, get positive x. And negative 3 I will move on this side, get positive 3. Just to remind you, every time you move over equal sign any term, you are flipping the sign. Positive will become negative, negative will become positive. And from here, x will be equal 7. Question number 5. Okay. Question number 5. 6 to power, wow, x squared minus 12. And it's equal 36 to power 2x. Very interesting. So 36 I can represent as a 6 squared, yes? To power 2x. Here I have 6 to power x squared minus 12. So it's going to be 6 to power 4x, right? 2 times 2x, 4x. 6 to power x squared minus 12. All right. So from here, base is the same. I can write down squared. x squared minus 12 is equal 4x. To solve this, we have quadratic equation, right? X squared minus 4x minus 12 is equal 0. Now we are going to FOIL it, which means we need to find two numbers that multiplication will give us negative 12, addition will give us negative 4. Whoever need to refresh the memory, at the end of the video I will put the link or reference to my video where I go over foiling quadratic equations. So here we will have practically, let me see, it's going to be x minus 6 and x plus 2. 6 times 2 is negative 12. Negative 6 positive 2 is negative 4. So from here, either x minus 6 is equal 0 or x plus 2 is equal 0. And we have x is equal positive 6, x is equal negative 2. Okay. So, what we're gonna do next, let's see, let's solve next question. Number 6, question number 6. It is gonna be 4 to power x plus 6 is equal 16 to power x minus 2. All right, so 4 and 16, I can represent 16 as a 4 squared, right? 4 to power 2 and to power x minus 2. Here we have 4 to power x plus 6. So 4 to power x plus 6 is equal 4 to power 2x and then minus 4. So base is 4, which means I can write down x plus 6 is equal to x minus 4. From here, I'm moving this x here because 2x I don't want to become negative, so get negative x. Negative 4 moving here. So what do I get? 6 plus 4 is equal to x minus x. 10 is equal 1x. And our answer, x is equal 10. Question number 7. Now we know what is the letter E, that mathematical element that has 3.217 and blah, 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 blah. So, and it's used in the very much in economical, in economy, in statistics, it shows the growth. Okay, so e to power 1 minus 8x equal 2,773. How we are going to solve this problem? So what I'm going to do, since here there is no way I can represent 2,773 as by base e in some power, so I can apply second method of solving the exponential equation, assign logarithms. Since I have e, I'm going to assign logarithm, natural logarithm, to both sides, so which is going to be logarithm here. I'm going to take natural logarithm here and here. This is going to be e to power 1 minus 8x equal natural logarithm 2,773. Okay, so from here, natural logarithm of e is gonna be equal, from here, 1 minus 8x, it's gonna be equal natural logarithm 2773. Why? Very legit question. Because based on inverse property, let me write down, natural logarithm of e by base x is equal x. So this is very important property. Okay, natural logarithm of e by base x is equal x, and that is based on that. Because of that property, I took natural logarithm and instead of logarithm with any other base. So natural logarithm was convenient because natural logarithm of e would be gone, and I would have 1 minus 8x. From here, it's not a problem, it's going to solve. I need to find x, which means from here, I will have negative x. I'm going to move here to get positive 8x, and natural logarithm bringing here. I will have 1 minus natural logarithm 2773 is equal positive 8x. And to get x by itself, I'm going to divide by x by 8 here and by 8 here. So this 8 is gone, and my answer is going to be x is equal 1 minus natural logarithm 2773 over 8. All right? Okay, so from here, if you want to get the the value of this, how much it is, so all you're gonna do, punch on calculator, natural logarithm of 2773, subtract from 1. Oh, let me see if you are interested. Okay, let me do it. How much it's gonna be? So I will tell you right away. 2773, whoever is using calculator of the iPhone calculator, punching 2773 and then taking natural log, and it is gonna be 1 minus 7 point, how many decimal notations to take here? I would say maybe 2 decimal notation would be good enough, which means it's going to be 7.93 over 8. And if you solve this, you are going to get negative 0.87. And that is going to be your answer. Okay? Question number 8. What do we have? 5 to power 5x minus 7 is equal 3 to power x minus 4. So how we are going to solve this equation? Okay, in the cases like this, so we have here 5 and we have 3, and we know that there is no way in the world we can bring to the same base, because we have 5 and 3. So what we're gonna do, we're gonna get assign natural logarithm or any other logarithm as a matter of fact. So I'm going to take natural logarithm, assign natural logarithm for both sides. All right, so, and this is gonna be 5 to power 5x minus 7 equal 3 to power x minus 4. All right, so from here, what do I have? I cannot drop here a natural logarithm because I can drop only if I have e here, right? So in this case, see, natural logarithm e. But here I'm taking as a natural logarithm 5, and I'm going to apply property of logarithm, and that property of power, where any log a to power p is equal, so this p is coming in front, power times logarithm a. Okay, so from here what I'm going to do, this entire 5x minus 7 comes in front, we put in parentheses, and it's going to be logarithm 5. Okay, and it's going to be equal, same way here, x minus 4 times natural logarithm 3. Okay, now let's distribute. So it's going to be 5x natural logarithm 5 minus 7 natural logarithm 5 is equal x natural log 3 minus 4 natural log 3. Okay, so from here, what am I going to do? I'm going to do the following thing. Take, since we need to solve x, I'm going to find out which ones are my like terms. So in this case, this is going to be my like term with this. Not like terms, but I can take common factor. I'm sorry. It's not a like term. It has to be both. Like terms will be 5x logarithm 5 and 7 logarithm 5. That is like term based on logarithm. Now in this case, since I'm going to solve for x, now I'm looking for terms that have x. So these two have x's. So therefore I'm bringing on one side, it is going to be 5x natural logarithm 5 minus x natural logarithm 3. And this is going to be equal. This negative 7 logarithm 5, I'm moving on the other side, will be positive 7 natural logarithm 5 and minus 4 natural logarithm 3. From here, I'm taking x out. I will have 5 times logarithm 5 minus logarithm 3 equal 7 logarithm 5 minus 4 logarithm 3. And from here, to get x, what is coefficient of x? It's going to be in here. 5 logarithm 5 minus logarithm 3, right? It's going to be dividing by 5. Logarithm 5 minus logarithm 3. The same way is here. 5 logarithm 5 minus logarithm 3. This is gone. We are cancelling to each other. And x is equal 7 logarithm 5 minus 4 logarithm 3 over 5 logarithm 5 minus logarithm 3. This is one of the methods to use when you cannot bring to the same base. Okay, that's when we use this method. Okay, let me write down here. Would write down this way. Use this method when you can't bring to the same base. There we go. So you sign logarithm and you go from there. Okay. All right. Next one. Oh, by the way, very important question. Just in case if you are wondering if you can use only natural logarithm, no, the answer is not. You can use any the common logarithm. B is logarithm by base 10, or by any other base, or 3 or 5 or any other base. Okay? Okay. Next one, question number 9. So, solving the following exponential equation: e to power 2x minus 3e to power x plus 2, and it is equal 0. Wow, this is interesting one. This is interesting one. Okay, so look, what do I see here? I have here 2x and here 1x, and here is available term. So what am I going to do? In cases like this, I'm going to use method of substitution and convert it into quadratic equation to solve. So if I take, let's say, y, replace it with e to power x, right? Replace e to power x. Look, what do I get? I will get, so e to power x, this e to power x, it's gonna be my y, right? So I'm getting y to power 2. If e to power x is y, then I'm getting y to power 2 minus 3y plus 2 is equal 0. So nicely I switch to quadratic equation. So let me FOIL it. So what do we have here? Y minus 1 times y minus 2 is equal 0. Negative 1 times negative 2 is positive 2, and negative 1, negative 2, it's going to be the negative 3. To solve it, so it's either y minus 1 is equal 0 or y minus 2 is equal 0. So from here, y is equal 1, y is equal 2. Like I said, at the end of the video, I will place reference to how to factor down, how FOIL a quadratic equation, exactly this problem. Now, since we have, what do we have? Since we have the substitution, y is equal 1 and y is equal 2. So in this case, so I'm bringing back, since y is equal e to power x, here I will have e to power x is equal 1, right? So, and here I will have e to power x is equal 2. So I replaced this y, moving to this y, right? Replacing e to power x equal 1, e to power x equals 6. So, equal to. What am I going from here? I'm going to assign natural logarithm because I have e. The best to assign natural logarithm, because we know natural logarithm by base e. Where is it? Let me move it down. Right here. So it's, if I take natural logarithm, so e to power x is equal natural logarithm 1. So from here we know that natural log e to power x is equal x. So from here my x is equal natural logarithm 1. So if you are interested to know how much precisely it is, just go to calculator and get the value of natural logarithm of 1. And let me do it for you. 1 and natural logarithm, that is gonna be, take a guess. It's gonna be 0. Why? Any degree, be it e to raise to power 0, is gonna 1. At the second, let me tell you, remind you something. Anytime when you have any logarithm with any degree 1, that means it equals 0. Yes? All right. And the same thing here. Natural logarithm e to power x is equal to, so from here we have x is equal natural logarithm 2, which is equal to natural logarithm 0.69. Let me make it approximately equal 0.69. So the solution we put like that, 0, comma, and 0.69. Okay. Moving to next question, question number 10. We have another one, 3 to power 2x plus 3 to power x and minus 30 is equal 0. Okay, one more time we are going to substitute. So it's going to be y is equal 3 to power x. Yes, y is equal 3 to power x. Okay, so from here what we are going to get, so 3 to power x I'm replacing with y, and it's going to be power 2 plus 3 to power x is y plus y and minus 30. So let's FOIL it down. It's going to be y plus 6, y minus 5 equals 0. I remember to place the reference to the video, and I think it's in my intermediate algebra playlist. So from here, y plus 6 is equal 0, and y is equal negative 6. Y minus 5 is equal 0, or y is equal positive 5. And then we are going to take the value that we have. So 3 to power x is equal negative 6, and 3 to power x is equal 5. Right? We bring back our y. How to solve such problem? Same way, we can take natural log. That's going to be natural log here, natural log here, and it is going to be 3 to power x equal natural log of negative natural log of negative 6. Well, interesting thing, we cannot have natural log of negative 6 because logarithm can never have negative number. So this one has no solution right there because of this negative under logarithm. So we have only one way. Put this one, natural log. Here I have 3 to power x, here I have 5. Okay, so if I solve this x come in front as a power, I get x natural log 3 is equal natural log 5. So to get the x by itself, I am dividing by natural log 3. This is gone, and I'm getting the answer, which is gonna be x is equal natural log 5 over natural log 3. Okay, so you can plug the numbers on calculator and get the result. Let me see. Five natural log is 1.61 and natural log 3 it's gonna be 1.1. So approximately it's gonna be 1.61 divided by 1.1, and we are getting 1.46. Question number 11. All right. What do we have? 5 to power 3x plus 5 is equal 7 to power x minus 3. All right. How we are going to solve this problem? Again, we have the problem that where base can never be brought to the same common base, same identical base. Therefore, we are going to use logarithm. Logarithm here, and we have 5 to power 3x plus 5 is equal logarithm 7 to power x minus 3. We have 3x plus 5 natural logarithm 5 is equal x minus 3 natural logarithm 7. So I'm going to distribute 3x times logarithm 5 will be 3x logarithm 5 and plus 5 natural logarithm 5. This is equal, let me clean this 5, it's ugly. Is equal x times logarithm 7, it's going to be x natural log 7 and minus 3 times natural log 7. Okay, we need to find x, so I'm put both terms that have x on the same side, which is going to be 3x natural log 5 minus x natural log 7, that is equal negative 3 natural log 7, and I'm moving this 5 natural log 5 on this side also, minus 5 natural log 5. Okay, taking x out from here, and I will have 3 natural log 5 minus natural log 7 equal negative 3 natural log 7 minus 5 natural log 5. So to get x, what do we have to do? Divide by 3 natural log 5 minus natural log 7. And the same thing here. 3 natural log 5 minus natural log 7. And x from here is equal negative 3 natural log 7 minus 5 natural log 5 over 3 natural log 5 minus natural log 7. Okay, and we are done. Question number 12. Question number 12. We have, now we are going to solve equation where one side already has log, the other side doesn't have it. X plus 23 by base 2 and it's equal to. Okay, so how we gonna do in this case? In this case we are going to represent in the form of exponent. Let me refresh your memory. Logarithm, let's say a by base b is equal c. So what do? B to power c is equal a, right? Is equal a. So in this case we are going to do 2 to power 2 is equal x plus 23. Okay, so let's go. 2 to power 2 is equal x plus 23. From here, 4 is equal x plus 23. And moving 23 on this side, it's going to be negative. 4 minus 23 is equal 4. Is equal x. And x is equal negative 19. Okay. Question number 13.